Hello friends, this video on electrochemistry part 14 is brought to you by examfear.com. No more fear from exam. Now let's see the Gibbs free energy for the Nernst equation. We have seen that delta G is nothing but minus NF E, and E is nothing but E of cell at any given concentration. This can be found by Nernst equation. Okay, this is the Nernst. Now if you can find this E cell, they can easily find Gibbs free energy also. Correct? So the standard electrode potential for Daniell cell is given. We have to calculate the Gibbs energy for this reaction. You know that delta G is nothing but NF E naught. Please note, this is E naught is given and need to find standard Gibbs free energy. That is, to find delta G naught. Let's put the values here. N is equal to 2. F is, we know, 96487 coulomb per mole. And E naught is 1.1 volt. So 1.1 volt I can write as 1.1 joule per coulomb. Right? 1.1 into joule per coulomb. Coulomb gets cancelled. You solve this, you get is a minus here, minus NFE, minus 21222 joule per mole, or you can say minus 21.222 kilojoule per, and that is my Gibbs free energy. Correct? The next question is why voltage of battery we use doesn't drop after use. So that's a good question actually. The battery generally we use the pencil battery, right? Or lithium ion battery. So in that case, it is not in the liquid form. The electrolytes are not in the liquid form. They are formed in the solid form actually, almost solid form. It drops, but it drops very less because it's almost in the solid form. And we have seen that when we talk about Q, solid concentration we almost take as 1. And that's why the Ln here is almost 1. Why? Because we are dealing with solids here, right? It's almost 1. And thus the voltage doesn't drop here because we know that E is equal to E naught minus 2.303 RT by N log of Q, right? And this is almost 1 because we are generally dealing with the solutes, right? So this is 0. So the voltage doesn't drop over a period of time for the normal battery we use in our life. The next question is write the Nernst equation and the EMF of the following cell at this temperature. See, to write the Nernst equation, the first thing is we have to write the balanced equation. So let's write the balanced equation for this. Mg becomes Mg2 plus. 2 electrons are exchanged. Copper 2 plus becomes copper solid. Correct? So for this equation I can write as E cell is nothing but E naught cell minus, since it is happening at 298 Kelvin, you can use this shortcut equation 0.059 by N log of K. Correct? That is what we can write. And log of K is nothing but, if you see the concentration of, here for this equation I write K is nothing but, log of Q. Q is nothing but concentration of Mg2 plus, concentration of copper solid, that is almost 1, divided by concentration of Cu2 plus, concentration of Mg solid. This is 1, this is 1. So that is my Q. And E naught cell we can actually find, right? E naught cell for this reaction is nothing but E right minus E left, that is E naught for copper 2 plus to copper minus E naught of Mg2 plus to Mg. Let's find this guy. E naught cell is E right minus E left. E right is nothing but copper 2 plus 2 copper minus E left is EMg2 plus 2 Mg. Please note this is Mg2 plus 2 Mg. Both I am writing reduction. So from the table I can say that copper 2 plus 2 copper is 0.34 and the reduction potential of Mg2 plus 2 Mg is minus 2.37 volt. Total is 2.71 volt. So I know the value of E naught cell. Correct? So let me put the values now here. So E cell will be nothing but E naught cell, that is 2.71 volt minus 0.0591 by N is 2 electrons log of concentration of Mg plus, that is nothing but this guy, 0.001 by concentration of copper plus, that is 0.0001. So this becomes log of 10. Log of 10 is 1. So you solve this becomes 2.7 V is V, right? Minus 0.0591 by 2 into log of 1 is 1. Log of 10 is 1. So you solve this becomes 2.71 V minus 0.03 V. You solve this, it becomes 2.68 V. So that is my EMF for this equation, the first equation. Let's do the same thing for the second equation. Right, so as we have done, first you write the balanced equation. Fe becomes Fe2 plus 2 electrons, and then H plus is reduced to hydrogen gas. There are 2H plus required. This is my balanced equation. Correct? I know that E cell is nothing but E naught cell minus 0.0591 by N log of Q. Correct? So let's see the Q value here. Q is nothing but concentration of Fe2 plus by concentration of H2 is almost 1 divided by concentration of Fe is almost 1 because it's solid by concentration of H plus to the power 2 because there are 2 H plus here, right? Please note there are 2 H plus, so I'm saying concentration of H plus to the power 2. E naught cell we can find easily using the chart we have. There is nothing but E of right minus E of left. What is in the right? Right we have this guy, that is E of reduction potential of H plus to H minus reduction potential of Fe2 plus 2 Fe. This is 0. This is, we know, is minus 0.44 volt. That is nothing but plus 0.44 volt. So I know E naught. So let's put everything in this equation. E cell will become E naught is 0.44 volt minus 0.0591 by N is 2 here, 2 electrons log of Q. Q is nothing but concentration of Fe2 plus, that is nothing but 0.001 M by concentration of H plus, that is 1 M, this square. Right? This is, should you not put M and all here, 0.001, 0.1, and this is more than enough. So you solve this, you'll get 0.44 volt plus, actually because this is 0.001, right? This becomes minus plus 0.089 volt, and that is nothing but 0.53 volt, and that is my answer. Because this becomes log of 10 to the power minus 3, so this whole thing becomes minus 3. So minus 3 into minus becomes plus, and you multiply this 0.059 by 2. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.